Bismillahirrahmanirrahim. Allahumma shalli ala sayyidina Muhammad. Okay guys, assalamualaikum warahmatullahi. Welcome to EET 306 Electrical Machines Lab number 4. Okay, today we shall perform a characterization of a squirrel cage single phase induction motor. Okay, as we have been done before regarding our squirrel cage motor of a 3-phase, and now the lab is focusing on the single phase module. But as we can see inside our PCM tools, we don't have a single phase module for induction motor, but we have 3-phase. And by right, the 3-phase and the single phase construction or motor, they behave or they use the same construction. Okay, it's just that in single phase the materials and the internal parts is cheaper compared to the 3-phase part. Okay, the objectives of this lab is to be able to we expect you all able to reconstruct, simulate and analyze the performance of 3-phase squirrel cage into single phase connection and use PCM to simulate the behavior or the response. And then when we change the parameters of the induction motor, we are able to understand or appreciate or observe the changes in terms of their performance, efficiency, and etc. Okay, here are the example of construction of 3-phase motor that we have been used before. And for 3-phase, we might have from 2 poles up to several poles of construction, but in single phase, usually we construct or we arrange in kind of 2 to 4 poles maximum. Okay. Okay, as you can see here, when we have a induction motor, we have terminal ports, and these terminal ports usually will be arranged or will be connected to the external connection. And usually we label this port or this terminal as U, V, and W, or this one, if in PCM, we label as A, B, and C, phase A, phase B, and phase C. Or in terms of connection, we shall connect to red, yellow, blue, whichever is okay. So this is incoming, which is U1, V1, and W1. And if we go in and we'll out here, U2, V2, and W2. Okay, if you see internally, the connection of this terminal will connect to the internal coil, and will go out at U2. So this in. Meanwhile, V1, it has connection into the terminal, into the internal coil, will rise at V2. And another coil, which is W1 here, will go out at W2. Okay. When we have this kind of motor being provided to the market, they will issue you one in terms of terminal connection. So usually you can see that the terminals either in connected like this. So all the U2, V2 and W2 are all interconnected, and they connect all together. Meanwhile, this part will be connected outside to the red phase, this one to the yellow phase, this one to blue phase. So what happened here is that we are constructing or terminating this kind of this motor into Y connection, So this one will be connected to your red, yellow, and blue terminal, red, yellow, blue. So this is Y connected. Because why? We have here the input of U1, V1 and W1. So this is your U2 here, V2 here and W2 are all interconnected. So this become Y or star connection. So this is applicable or being used, applied to the high voltage connection, which is maybe 415 volt of voltage. But when we reconstruct into low voltage application, we shall construct them in terms of delta connection instead. Okay, so all of terminal will be connected to the low voltage, let's say 240 volt. Okay, for this experiment, we shall reconstruct and all of the terminals that you have from your simulation PCM tools, which we have these 6 terminals, U1, V1, W1, V2, U2, W2 here. You will construct, instead of you use as previously in in Y connection, you will reconstruct into delta connection. Okay. So what happened here is that we have only single phase. So we shall use the capacitor run and capacitor start in terms of run and start and run of the motor. So this delta connection. So we have delta connection here. We will connect to 240 volt. Let's say if you use 240 volt as your terminal voltage, and another terminal will be connected to your capacitor. So we have here a single phase connection. Okay, this is the concept that we shall use inside our simulation and approach in our lab 4 here. So in figure 2, it shows you the concept of the single phase operation. You can see that normally we have in single phase terminal, we have only 2 terminals. And so the 2 terminals will be connected to the main coil and also the start coil. So what happens is that we have here, we have to have at least 4 coils, and 4 coils for this kind of capacitor run and capacitor start motor. So we provide the rotating electromagnetic field throughout this coil, and so it will rotate accordingly and generates the flux and also the force to turn the rotor. And once the rotor starts to rotate, so we can take out already this switch, and we can disconnect this switch, so it will continue to run with only the running coil, and it will run with the running coil. What happens if we don't take out the starting coil? So we shall, means that the pole is high, we have 4 poles, so the speed is going to be reduced. So it will not ramp up to the rated speed if we still connect the starting coils here. So it remains at 4 poles, the speed will be reduced. So if we take out the 4 poles to become only 2 poles, so the speed will raise up to the rated speed. Or else we can reduce the strength of the poles here. We use the starting pole and then we convert into running pole, but still in 4 poles, but with the less intensity of your flux or intensity of your field. So it will still continue to run at the rated speed, and the speed will raise regardless the pole is still remain at 4. So figure 4 shows the connection of in the star connected that we discussed before, but when we rearrange into delta, which is going to be applied to our lower voltage rating, and also when we want to include our capacitor. So in the real life connection, it will be terminated like this. So the bars will be connected between W2 and U1, V1 with U2 and W1 with V2. And okay, as previously explained, when we start with the 4 poles, so the torque will be high. So that's the requirement of our starting behavior. So we can pull or we can run the load, because normally the motor will be started with loaded, usually with full load. So we have to have some sort of high power or high torque ability of the motor to drag or to work the load. So when we have 4 poles applied to the system, so the torque is high, so we have a higher torque. But if we don't disengage the poles, the 4 poles, so it will start to reduce in terms of efficiency and in terms of the torque up to the rated speed. So what happens is that we have to change from the starting coils into the running coil. So from here we can interchange and change from the starting coil to the running coil behavior. So it will start to change and it will maintain the torque up to the rated speed, and the efficiency also will be, and the speed regulation also will be stable. You can see here. So what happened here and what we need here is that you run at the, you plot this graph, you run at the starting capacitor behavior, you plot this graph, and then you run with the running capacitor. So you plot this graph. So you suggest in terms of what is the switching duration of your system. So each of you maybe use different kind of capacitor values. So we expect you have maybe have the same trend, but maybe at different kind of switching section or switching period. So the task that you work in team, reconstruct, reconnect in terms of delta connection, and use 400 microfarad as your initial value. And then in section B, you can reduce down to 10% or 20% of the value and repeat what you done in A. And then you repeat B, means that you don't have to simulate again the section A, but you repeat in terms of the running capacitor here with several input terminal voltage adjustment. And so it means that maybe you at the first time you use 240 volt, so you reduce to 10%, maybe 220, 200 volt, 180 volt. So you can see, try to foresee what is the trend of your running torque here, running torque speed behavior here. Okay, that's all for your task. And given here are the rubric to represent the marks that you, or the things that you should focus on. Okay, that's all for the task of lab 4 here. Good luck, and the due date will be advised. Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh.